times x, and then x times 3, and 1 times x, 1 times 3. Okay, so what does that simplify to? X squared plus 4x, if we collect like terms, plus 3. Good. Okay. Can you expand the next two? Please expand both of those. Okay. FOIL them out. Collect like terms, which will always be your middle two, right? Usually, I should say not always, usually your middle two. Be very careful with signs on the last one. A positive times a negative gives you a negative. So, what did I do here? First I went x times x, which gave me the x squared. Then x times 5, 5x. Then negative 5 times x, negative 5x. And then negative 5 times 5 gives you the negative 25. Okay, so collecting like terms, what's your final answer? X squared minus 25. Good, the middle terms cancel. They add to 0. Okay, so looking back, if you compare to the top, 2x squared plus 10x can actually factor to be, if we go backwards, 2x plus 5, if we're comparing it to the numerator, right? So we could say 2x squared plus 10x is equivalent to 2x times x plus 5. Would you agree? Because we expanded and that's what we got. So to go backwards. X squared plus 4x plus 3 would be equivalent to what? Looking up. X plus 1 times x plus 3. Don't worry, you don't have to figure out how to get there just yet. We're just comparing it to the top. To what we just did. We just expanded. So 2x squared plus 11x plus 12 is equivalent to what? That's what we got here. So it's equivalent to 2x plus 3 times x plus 4. Written as a factor. See, it's called factors because it's changed to a multiplication statement. Just like the factors of 6, you could say 2 times 3. 2 and 3 are factors. 2x plus 3 and x plus 4 are factors of 2x squared plus 11x plus 12. Okay, x squared minus 5 could be written as a product of x squared minus 25 can be written as a product of x minus 5, x plus 5. Okay, so what we're going to do is this is going to be today's lesson, the first example. That's what we're going to do today, which is Wednesday. Okay, we're going to spend Thursday, Friday, and Monday on factoring, so turning x squared plus 4x plus 3 into that product, those two types. One is called a simple trinomial, or type 1, and this second one's type 2, complex, because this one has an a value of 1, this one has an a value of 2, or higher. And then the last we're going to do on Tuesday. Okay, that'll be Tuesday. Okay, so that's what we're going to do this week. Or this week and part of next week. So let's turn the page. So let's talk about common factors, the greatest common factor. Okay, we're actually going to go down to number 2. So when we are common factoring or finding out the greatest common factor, we want the largest number that will divide into both. Okay, largest monomial that divides into both of them. 12ab and 15a squared b cubed. Now knowing your times table is going to make this a lot easier. Okay, because if I wanted to find the greatest common factor to 12 and 15, I could just list all the factors first of 12 and 15. That would take some time. Agreed? 1, 12, 2 times 6, and 3 times 4. 15 is 1 times 15 and 3 times 5. What's the greatest common factor? 3. 3 is the greatest common factor. So if you know your times tables, it's a lot quicker. 12 and 15, what's the largest number that divides into both 12 and 15? 3. Okay, now a and a squared. What is in common? What can we pull out of both? It would just be 1a. 1a we could divide both by. I couldn't divide 12ab by a squared because that would give me a negative exponent. But we could divide it by a. Okay, so it's really what we're looking for. It's going to be the lowest exponent. If we look at a and we look at a squared, the lowest exponent, that is a. B and b cubed would then just be b. So our GCF is 3ab. Why? Can you divide 12ab by 3ab? Yeah, that gives you what? Or just 4. The a's and the b's cancel. Can you divide 15a squared b cubed by 3ab? Yeah, it gives you 15 divided by 3 is 5. A squared over a. B cubed divided by b. B squared. We subtract the exponents. Okay? So we're looking for the largest monomial that will divide into both of them. Is that making sense? The more we do, the easier it'll probably get. So 18 and negative 24. What's the largest number that divides into both? Yeah, and the easiest way is take your smallest number, look at its factors, if you don't know right away, and say, okay, will 18 go into 24? No. Will 9 go into 24? No. Will 6? Yes. So 6, x to the power of 3 is x4, x cubed. The highest in common is x cubed. And then y to the power of 2. Do you want to try C on your own or together? Together, okay. So if we don't see a coefficient, what's the coefficient? It's a 1. So looking at 1 and 2, what's the largest number we can divide both of those by? Just 1. Okay, 1. Do you have to write the 1? No. Could you? Sure. A cubed and A. Do they have a B in common? No, so it's not part of the GCF because only one has a B but the other doesn't. How about C squared and C to the 7? C squared. So 1AC squared, or you could just write that as AC squared is the GCF. Yeah. You take the lowest exponent. So the second one had no B. That's the same thing as B to the 0. And that's why the lowest exponent is B to the 0. Yeah, we take the lowest. Negative 40, negative 20, negative 10. If they're all negative, the negative's part of the GCF. Okay? So 40, 20, and 10, what's the largest number that we can divide into all of those? 10. So we'll write negative 10. A cubed, A squared, lowest, A squared. B cubed, B squared. B, lowest is B. There you go. Okay. So what we want to actually do is that's just looking for the GCF. We want to be able to factor out the GCF. And so once we find the GCF, we're going to write it into a form of multiplication. We're going to say, okay, then what's left over? If I pull out the GCF, and change it into a product, what's left over? So let's give this a try. What would be the GCF of 21x and 14y? 7. The GCF is 7. So we're going to put 7. Uh-oh. Uh-oh. Oh, we're good. No, we're not. Yep. Yep. I break things. That's my thing. Yeah. Okay, no. Okay. We look okay. We're looking okay. Okay. Let's try this again. So GCF is 7. And so how do we figure out what's left over? Well, we divide each term by our GCF. And so 21x divided by 7 is 3x. And then 14y divided by 7 gives you the 2y. Could you check your work? Yes. If you use distributive law, you should get back where you started. 7 times 3x, 21x, 7 times 2y, 14y. So that's my check. I can expand it. Oh yeah, that's where I started, so I factored correctly. Okay. So, out of B, what's the GCF? What number? It's the largest number you can divide by all three. 5x to the 2. And so when you divide, you have to divide each one of these by 5x squared. That's where, oops, that's not an eraser. That's better. That's where the inside of our bracket, we're turning it into a multiplication statement. So 5x to the 4 divided by 5x squared is 5x squared, or is just x squared. Do you see where what we're doing now? Kind of? Sure? Possibly? Okay, let's go to A, the next question. So they already told us what our GCF is. It's 5a. When we pull out 5a, we're left with a plus what? 5 or 5a? 5, because we're dividing both by the 5a to figure out what's inside. Okay, so if I factor 2 out of 18 and 16, what are we left with? 9p minus 8q. 18 divided by 2 gives you that 9. Okay, so let's try this on our own. Factor each polynomial by removing the GCF. 20x minus 6. What can we divide both those numbers by? Well, can 6 go into 20? No. Can 3 go into 20? No, but 2 can. So 2 is our GCF. So we're going to factor 2 out. So if I factor 2 out, what's left? 10x minus 3. And so how can we get those numbers? We divide each by the GCF. 20 divided by 2 is 10. 6 divided by 2 is 3. Okay? B. What can we divide both of those by? 4 and then x to the power of 2. So we want to figure out what is left over when we factor that out. 16 divided by 4. 4. X to the 4 divided by x squared. X to the power of 2. Now, what 4x squared divided by 4x squared? 1. Anything divided by itself is 1. Right? So remember, we divide each by the GCF to figure out what's inside the brackets. Good? Want to try C on your own? You can just try. Okay, do you want me to do C with you and you try D? Okay, so 10, 8, and 2. So 2. We can divide all of those by 2. Okay, a cubed, a and a, just a. B squared, b cubed, and b to the 4, b squared. So divide each by 2ab squared to figure out what is left over inside.
Do the brackets like that matter?
Oh no, you could do round brackets, sorry. They're, yeah, parentheses. There we go. Bracket. Is that better? Okay. So 10 divided by 2 is 5. A to the 2. A cubed divided by A is A squared. B squared divided by B squared. Gone. Cancels out. Plus 4. B. The A's cancel. B cubed divided by B squared is B. Plus 2 divided by 2 is 1. So 1b squared, or you could just write b squared. And that's the factored form. What time is it? It's part E time. Okay, try part E. Yes, you are. Try it.
I'm protesting.
It looks worse than protesting. It's party time. 5. It's what? It's like any multiple guys. So your GCF you should have is 5xy squared z squared. That's what your GCF is going to be. Okay. 5z minus 4xy squared plus 6x cubed z cubed. Is that a 5 or a 3? It is a 5. Okay. So z cubed. Okay? So check your answer. How was that? So looking at this page 6, we're going to look at number 2. Just number 2. Okay? So if the area of a cone is pi r squared plus pi r s, what can we factor out? What is a common factor for those two terms? Pi, what else? R. We can factor out a pi and an r. Okay? So pi r squared divided by pi r, what's left over? Divide both by pi r. So pi r squared divided by pi r, what's left over? R, right? R squared divided by r is just r plus s. Okay, so turning on to, can you flip to lesson 2? Let's look at something like this, okay? In certain circumstances, the greatest common factor, guys, Brayden. Okay, in certain situations, the common factor may be a binomial. So your GCF can actually be a binomial in certain situations. So like the situation below, okay? What I want you to do is expand your mind a little bit and think of this 4x times x plus 7 as one term and 3 times x plus 7 as another term. Why? Because terms are separated by plus and minus. So imagine that there's one term and two terms. What is common with those two terms? An x plus 7. So we are actually going to factor out x plus 7. And when we factor out a number, we divide each of those terms by the GCF. So when I factor x plus 7 out, please pay attention to this because it's really weird. What's left over? A 4x plus, or no, not plus, minus a 3. And that's it. Now you're done. Now it's factored. FOIL would be expanding. So by factoring, we want to turn it into multiplication.
We're not expanding anymore?
No, we're not expanding anymore. No, I know, darny. Okay, so if we treat, there's one term and two terms, what's in common? What's our GCF? 3 minus 2y. So that's going to be the GCF we're going to pull out and put in front. And you got it. And so what's left over when you factor it out? 7 plus 2y. Okay, like if you think of it like this, if I had 7a plus 2ya, if it was just like that, what would you factor out? The a. And you'd be left with 7 plus 2y. Well, what is a? A is 3x minus 2. Or 3, it's not 3x. 3 minus 2y. 3 minus 2y. That is your a value. Okay, so sometimes when it's a binomial, it's hard to see. Next one, what's in common? 4a plus 1. If I pull that out, what's left over? What's the coefficient if you don't see it? 1. So 9a plus 1. Because if you factor out 4a plus 1, right, you divide 4a plus 1 by 4a plus 1, anything divided by itself is 1. You get that wrong. You have to have the plus 1. Okay? A. I did sound it. What's in common? Okay, so if I factor 3y plus 2 out, I'm left with, what's left over? If I'm pulling the 3y, 5y plus 1 plus 4y. Can we collect like terms there? Yeah. 3y plus 2 times 9y plus 1. The 5 and the 4 y's.
Wait, wouldn't it be 9y squared?
No, we're adding like terms. So when we add like terms, right, we just add the coefficients, keep the variable the same.
So it's 3y plus 2 times 9y plus
1. Yeah. Okay, next one, what can you factor out? A minus 6, and we're left with 3a minus 9. We're not done. Why? Anyone see their issue? Okay, does one of these factors have a GCF? Yes. 3a minus 9, does it have a GCF? Yes, has a GCF of 3. And so we need to pull that out. If we can common factor, we must common factor. So where are we going to put the GCF? We're going to put it in front of the two brackets. Because it's weird to write it as a minus 6 times 3 times something. Like you wouldn't put a coefficient in the middle. That's weird in math world. That's where we draw the line. Yeah, that's where it gets weird. So we put the 3 in the front, right? Coefficients in the front. So if you factor 3 out of 3a minus 9, what's left over? A, divide both by 3. A minus 3. Yeah, it's crazy. 2x times x minus 5 plus 5 times 5 minus x. Are these the same thing? No. Why not? They are different. Okay, looking at the x's, no. Looking at the x's, what's the sign of the first x here? Positive. What's the sign of the second x? Negative. So they're not the same. Now, how can we make the signs the same? It's just like when we subtracted, we changed it to addition, right? We're going to change the signs of the second one. So what we're going to do is instead of having a plus 5x, we're going to make it negative 5x, and that will switch the signs inside. So that would it's as if we're factoring negative 1 out. We're pulling out a negative 1. We're making it subtraction by switching the sign. So instead of a positive 5, we're going to have negative 5 instead of negative x. We're going to have, are those two things the same now? Is x minus 5 the same as yes. So now we can factor out x minus 5, and we're left with 2x minus 5. It's crazy. Okay, so now these two are the same thing, just written differently, but they are identical. It's like a, b, and ba, same thing. Or a plus b, b plus a. Those are the same thing. So you can factor that out. Yeah. Okay. Okay, let's move on to example 3. Yes, and this is it. This is it. After we're done. Then we're done for today after this part. Okay? Well, remember we handed back our. I know there is. There is. This is a tough unit, and you're gonna have to fight through it. There's a lot of homework because you need lots of practice. Okay? Let's get going so we can get stuff done in class and you can ask questions. A, what do we do when we have 4 terms? There's something called grouping. Okay? So what do? We group the first 2 terms and we group the second 2 terms, and we're going to find the GCF individually for each group. Okay? So we're grouping these 2, we're grouping those 2. We're setting them into pairs. Okay? So the first 2, what is a GCF for the first 2? X. The first 2 have a GCF of X. And what are we going to do then? We're going to factor out the GCF for the first 2, okay, of the X. If I factor out X from the first 2, what am I left with? X squared divided by X is X. 3X divided by X? 3. Okay? Now I'm grouping the second 2, and I'm finding the GCF for those 2. What can you divide 16x or 6x and 18 by? 6. Okay. Now this was addition, so we have to write plus 6. We need to have that sign there. And let's figure out what's left over. X plus 3. Hey, do we know what to do from there?
Yes.
Okay, Kieran, what do we do?
X plus 3.
Times?
Yeah, times 6.
X plus X plus 6. Okay, so factor the X plus 3 out, yeah. If you had 6 plus X, 6 plus X is totally fine. If you wrote 6 times X, not the same thing. Yeah. Okay, so group the first 2. What can you divide the first 2 by? 2 and X. What can we divide the second 2 by?
4, 3.
3. The GCF is 3. So you're going to factor 2x out of the first 2, and we're going to factor plus 3 out of the second 2. Okay, what's left over? 4x minus anything divided by itself? 1. 12x divided by 3 is 4x minus 1. It should be the same. They should end up being the same. If they are, you're on the right track. 4x minus 1 times, we're factoring the 4x minus 1 out, and we're left with 2x plus 3. Okay, try C. 8a squared minus 4a, the largest number we can divide into both. 4 and a. So we're factoring out 4a. So divide both by 4a. What's left over? 2a minus 1. Okay. Now, if you just brought out plus 5 for these two, okay, let's say, don't write anything down yet. If I factor out plus 5, what am I left with? Negative 2a plus 1. What's wrong with that? Are they the same or the signs opposite? They're the opposite sign. So if the first one is negative, so the negative 10, let's factor out the negative with it because we want to make sure the signs are the same. So I'm going to factor out negative 5. Will that give me the signs I want? Negative 10a divided by negative 5. Positive 2a. What's a positive 5 divided by negative 5? Negative 1. Are those two the same now? Yes. So 2a minus 1 times 4a minus 5. Do you want me to go through another example? I think we should.
Could we try on our own?
Can you try D on your own? All by myself. Try D. All by yourself. Okay, 5x squared plus 18y squared minus 15xy squared minus 6x. Sometimes when you group, and I want to go through this one with you too. Sometimes when you group, it doesn't work out. So in this example, 5 and 18, is there a GCF? No. X squared, no. So just 1, and I'd be left with 5x squared plus 18y squared. Don't write this down just yet. Okay, is there a GCF out of those two? 15 and 6, what can you divide those by? 3, they're both negative, so negative 3, and what else? X. So I did that. Oh, did it work out this time? Let's see. Negative 15xy squared divided by negative 3x. 5y squared. Uh-oh. Plus 6x divided by plus 2. Okay, did that work out? No, it didn't. Sometimes that happens. In the event that happens, we rearrange. So let's rearrange our groups. Okay, so let's try 5x squared and then minus 15xy squared plus 18y squared minus 6x. Let's try that. See if that works. Okay, so group the first two. What can we divide both of those by? 5 and x. So we'd be left with x minus 3 and y squared. Okay, these two. What can you divide both by? 6 is even larger. 6, and we're left with 3y squared minus just x. Now, are those the same? Close. What's wrong? The signs need to switch. So we'll leave it. We'll change this to, instead of a plus 6, we're going to make it -6, and the signs will switch. Is this the same thing? Now it is, so we can factor out x minus 3y squared, and we're left with 5x minus 6. Okay, so sometimes the grouping didn't work. You have to rearrange until you find one that does. Okay? Now, your homework for tonight, page, it's on your sheet, but I will write it down. 324, a bunch of it's really quick GCS stuff. 3 to 7 ACE, ACE, 8A and 9A, 10 and 12 to 16. And page 331, numbers 1 to 4 AC, 11 to 13. And then booklet page 35. Yep, I'll give you the booklet. Okay. I'll show you what that is. That's going to be a handout. Okay, it's a handout.